All right, class, we are now into, we are now into Hooke's Law. So the first thing that you want to do is go ahead and download your Spring Constant Analysis Calculator. We don't need anything else. In fact, let me refresh this, and one of these PDFs should go away. It's the Hooke and Bernoulli lecture notes should go away. But okay, so go ahead and download that. And let's just take a quick gander at this to see what we're going to be looking at. We have our first compression position. So this is some of the work that we just did, okay? Or it's the work that we did in the last experiment. And we have our second and our third, and then we have Hooke's Law. Some of the things that I'm going to want to look at, I want to look at like the initial velocity that's produced, and I want to compare it to the kinematic theory initial velocity that we have for the first click, the second click, and the third click. You guys did this in experiment number 5, and you also did it for the midterm initial velocities. So we have our second compression, that's our second click. Third compression, that's our third click. And we'll be able to analyze the differences between our velocities produced from each one of those kinds of experiments. It's a little aside from Hooke's Law, but that's okay. We have our mass of the ball, our initial velocity that's going to come from our experiment, and we have our compression length. So I've already calculated or measured the compression lengths, and these compression lengths are 3.4, let me see, 0.03473. This is the kind of precision we're getting because I'm using a micrometer or a caliber, a digital caliper. And so we have 3473, and then we have 0.04738, and then 0.06372. So you see that this is increasing. Now we have our spring constant here that's going to be produced as a result of this, and we'll talk a little bit about that. And we have some graphs here. We have initial velocity versus compression, and then we have what's this? It's saying the constant versus compression. So we'll look at those. I think that I'm compressing, and then I want to look at the constant. And I'm compressing, and I want to look at the initial velocity. That's really what's happening. So the compression is independent from the velocity. The velocity is dependent on the compression. Can y'all dig it? Okay, let's move on from here. Let's go ahead and put this into our folder. And we're going to talk about a little bit of theory when it comes to Hooke's Law and how we're going to utilize it. So of course I want to put it on Dropbox, guys. Let's just wait. It says opening. I'm going to go ahead and duplicate this. And let's find out where this is going to go. This is going to go into Hooke's Law. And in Hooke's Law, let's call this Hooke's calculator. So now that we have that, let's go ahead and build up some notes here real quick. Just gonna minimize. It's gonna probably go away. I haven't had this open for a second. So there we go. I'm gonna go ahead and create a space here, and let's call this Hooke. All righty. So now that we have Hooke's Law,